This is Algebra 2, still on our unit of prerequisite skills, and we are going to solve compound and absolute value inequalities. So compound inequalities are when we have two of them put together. We are going to have and or, and we are going to solve for the variable, write the solution on a number line in set builder and interval. So first example, we have 13 is less than 2x plus 7 is less than or equal to 17. There are two ways that you can solve these. The first way is you can split this up into two equations. One of the equations would be 13 is less than 2x plus 7. And then you would say and 2x plus 7 is less than or equal to 17. All right. Or the other way that you can solve this is you can solve it all at once. I'll illustrate it to you. So the first way, you would subtract 7. You get 6 is less than 2x and then divide by 2. So 3 is less than x. You would subtract 7 from your second equation and get 2x is less than or equal to 10, and then divide by 2, so x is less than or equal to 5. Notice you did the same exact two steps to both equations, so you can actually do that all at once. So here, if I want to subtract 7, I'm going to subtract 7 from all sides. So I get 6 is less than 2x is less than or equal to 10. Then to get my x alone, I can divide by 2. But divide by 2 everywhere, we get 3 is less than x is less than or equal to 5. And now here, this is already written as a compound for us, and that is how we want to write our solutions. Whereas up here, we would still have to combine them together. So set builder, you put your x such that out in front and then put your curly brackets around it, and there we got set builder. Number line, let's see, we need a 3 on there, we need a 5 on there, so we'll put the 4 right in the middle. 3 is less than x is less than or equal to 5. As long as those inequalities are going the same direction, that tells us that we're shaded in between. So we'd have an open circle at 3, a closed circle at 5, and we are in between 3 and 5. Because this is really telling us here that x is greater than 3 and x is less than or equal to 5, so we're somewhere in between there. And then interval, we are starting at 3. And it's an open circle, so we'd say parentheses 3, comma, we are ending at 5, and 5 is included, so we would put a square bracket. The other type of equation you can have is an or. Or means that both of the solutions in their entirety are solutions. So you solve them both individually. So y minus 2 is greater than negative 3, or y plus 4 is less than or equal to negative 3. So solving this first one, we'd start by adding 2. So we have y is greater than negative 1. Or, second equation, you'd subtract 4. So you'd have y is less than or equal to negative 7. That is your solution. So you'd put your curly brackets in your y such that this is set builder. Okay, now on a number line, you need negative 1 and negative 7. So there we have negative 1 and negative 7 on there, and you graph them both. So if y is greater than negative 1, that's an open circle at negative 1 going to the right. If y is less than or equal to negative 7, that is a closed circle at negative 7 going to the left. So there's your number line. Notice both graphs are graphed on there, and they're both all included. Interval, you look left to right, you see over here, this arrow is heading to the left, so that's negative infinity. And then it stops at negative 7, which is included, so square bracket. Then our graph picks back up at negative 1, which is not included, so parentheses, and it heads off to the right forever, which would be infinity. So their interval, we just have two separate of our parenthesis brackets written right next to each other. All right. Let's try a few more of these. 2 is less than 2x plus 1, which is less than or equal to 17. So we'll solve these all at once. So subtract 1. So we have 1 is less than 2x is less than or equal to 16, and then divide by 2. So 1/2 is less than x is less than or equal to 8. So that is our set builder if we put curly brackets in the x such that. Okay, number line. Let's see, we need 8, we need 1/2. So I'm going to just go by even numbers here, and then to indicate the half, I'm just going to put this little tick mark right here and write 1/2 right above it. So we have an open circle at half, a closed circle at 8, and shaded in between. And then interval, we start at a half, not included, so parentheses. We end at 8. 8 is included, so square brackets. So there's our three ways to write it. Next up, y plus 7 is less than negative 4, or y minus 10 is less than 11. So we're going to subtract our 7 to get y is less than negative 11, or here we will add our 10 to get y is less than 21. So on our number line, we're going to need 21 and negative 11. Now before you put anything in between here, let's just look and see what happens. If y is less than negative 11, it's an open circle at negative 11 going to the left. If y is less than 21, it's an open circle at 21 going to the left. And now what do you notice? Suddenly negative 11 becomes included, and the only thing that really matters here is that we are less than 21. So this is actually the only solution that would describe this number line we just drew. So our set builder is just y such that y is less than 21. So in interval, we can start here at negative infinity and end up at 21. Okay, so sometimes when we have ORs, one of the equations for ORs will just be kind of included in the other, so we don't need to write them both down. We just write down the one that includes them both. One more OR problem. 3x plus 7 is less than 4, or 6x plus 23 is greater than negative 1. So to solve this first one, we'd subtract 7. So 3x is less than negative 3. Divide by 3, so x is less than negative 1. Next up, subtract 23. So 6x is greater than negative 24. Divide by 6, so x is greater than negative 4. Or, so on a number line, we should have negative 1 and negative 4. So if x is less than negative 1, here we're at negative 1, and we're going to the left. So there's x is less than negative 1. If x is greater than negative 4, here we're at negative 4, and we are going to the right. And now, notice what just happened to our number line. Our entire number line is shaded in. So what does that mean? If our entire number line is shaded in, that means all the values of x that work, that x is a real number. Anything works. Okay? Every single value that we can put on that number line works. There is a shortcut for real number. It is a capital bold R. That stands for real number. All right? And then interval here is we are off to the left, so that's negative infinity. And we don't stop anywhere throughout this number line, and then we are off to the right, so that is positive infinity. So negative infinity to positive infinity would be our interval. Okay? So those last two examples were kind of special things that can happen with ORs. So let's talk about some absolute values. Absolute values, depending on the sign that's next to it, is either going to be an and or an or. So absolute value of a is less than 4. This gives us two equations. A is less than 4 and negative a is less than 4. Same way how we got two equations from our others. If negative a is less than 4, to get the a alone we have to divide by negative 1. So that means a is greater than negative 4. So on the number line here, we have 4 and we have negative 4. If a is less than 4, that would be to the left of 4. But then over here we have a is greater than negative 4, so that would be to the right of 4. Notice how this looks. This looks more like an and problem. So when you see the less than sign next to an inequality or next to an absolute value, that means it's an and problem, so you're going to solve it like an and problem. So here our solution set would be a such that negative 4 is less than x is less than 4. Negative 4 is less than a is less than 4. And you can do that by putting these two together or simply by looking at that number line. And then here interval, we start at negative 4, we end at 4. Neither are included, so we put them both in parentheses. Okay, which means that this next one most likely is an and. We'll just check it. So we write out our two equations. A is greater than 4, negative a is greater than 4. Divide by negative 1, so it flips the sign. So a is less than negative 4. So on the number line we have 4 and negative 4. If a is greater than 4, that goes off to the right. If a is less than negative 4, that goes off to the left. And sure enough, this looks like an or. So greater than signs next to absolute values mean or. So here set builder would be a such that a is less than negative 4 or a is greater than positive 4. Interval here, we're off to the left, so that's going towards negative infinity. Then we come and stop at negative 4. We pick back up at positive 4 and we head towards infinity. All right, so when we're solving these absolute values with inequalities, we need to look to see if we have a less than sign or a greater than sign. If it is less than, we're going to view it as an and. If it's greater than, we're going to view it as an or. All right, so 3x minus 12, the absolute value of that is greater than or equal to 6. So greater than or equal to, we're going to view this as an or. So two equations. 3x minus 12 is greater than or equal to 6, or negative 3x minus 12 is greater than or equal to 6, or. Solve them. So plus 12. So 3x is greater than or equal to 18. Divide by 3. So x is greater than or equal to 6. Okay, next up, distribute the negative. Negative 3x plus 12 is greater than or equal to 6. Subtract the 12. So negative 3x is greater than or equal to negative 6. Divide by negative 3, so x is less than or equal to 2, or. So on a number line, we're going to need a 2 and a 6. If x is greater than or equal to 6, that's a closed circle at 6, going off to the right. If x is less than or equal to 2, that's a closed circle at 2, going off to the left. So our set builder would be x such that x is less than or equal to 2, or x is greater than or equal to 6. Interval, we're starting at negative infinity. We stop at 2, it's included, so square bracket. We pick back up at 6, it's included, so square bracket, and then we go to infinity. So those are our three ways of writing the solutions. All right, next one, absolute value of 7x plus 4. And then plus 6 is less than 4. So we need to get the absolute value alone first. So we're going to subtract 6 from both sides. Absolute value of 7x plus 4 is less than negative 2. Less than means and. And there's something else you should take note of. There's a negative sign here. What do we know about absolute values and negative? They can't be negative. Now this is an inequality, so we need to think about this. This is saying less than negative 2. Are all numbers less than negative 2 negative? Yeah, they are. So this is no solution. It'll never work. Okay. Let's do just a couple more. Absolute value of negative 3g is greater than or equal to negative 9. All right, this is alone. Greater than or equal to, so this will be or. Oh, but once again, we see a negative here. Okay, so let's think about this. Here we are greater than negative 9. If we're greater than negative 9, will we eventually get positive numbers? So our 0, 1, 2, 3, 4, are those all greater than negative 9? Yes. So what does that tell us? That tells us every single value, every positive value is greater than negative 9. So we can get solutions. So let's solve this and figure out what solutions we do get. So we would have negative 3g is greater than or equal to negative 9, or negative 3g is greater than or equal to negative 9. First one, divide by negative 3. So g is less than or equal to positive 3. Second one, 3g would be greater than or equal to negative 9, so divide by 3. So g is greater than or equal to negative 3. On a numbered line, get our negative 3 and our positive 3. If we're less than or equal to 3, so closed at 3 going to the left. For greater than or equal to negative 3, that's a closed at negative 3 going to the right. So what happened to this number line? Everything's included. So this is all the values for g such that g is a real number. Or we go from negative infinity to positive infinity for our interval. And last but not least, absolute value of 5x is less than, I am going to make this into a positive 2. So we already did an example for negative. So less than, this means and, so we're going to split up our two equations. So 5x is less than 2 and negative 5x is less than 2. So we divide by 5, so x is less than 2/5, and we divide by negative 5, so x is greater than negative 2/5. So on our number line, we should have a 2/5 and a negative 2/5. We are greater than negative 2/5 and less than positive 2/5, so we are in between these. So set builder all the values for x such that negative 2/5 is less than x is less than 2/5. And then interval notation would be negative 2/5 to 2/5, both in parentheses because both are not included.